Happy New Year from myself and our fourth grade team, and welcome to our first flip video of the new year. As usual, if you have any questions, please ask myself or Mrs. Drake, and please make sure that you pause this video at any time that you need to. So let's get started talking about fractions. First, we have the denominator. This is the number on the bottom of the fraction. This number represents how many total pieces there are of a whole. Numerator. This is the number on the top of the fraction. This number represents how many pieces you are comparing. So go ahead and record this on your recording sheet. And again, pause if you need to, but I'm going to move on. Let's talk about this. This is one whole of whatever you want to call it. If you want to call it a pizza or if you want to call it a cookie, this is one whole cookie. We split the cookie into 5 pieces. That's the denominator. The numerator is how many pieces we're talking about, whether this is how many pieces are left over or how many pieces were shared, and that's represented by this number 2. So the numerator is the part shaded in and the number 2, and the denominator is how many total pieces there are. So what is this fraction? Well, how many total pieces are there? That's going to be your denominator. So there's 1, 2, 3, 4 total pieces. Your numerator is going to be how many are shaded yellow, and that would be 3. So this fraction is 3/4. 3 out of 4 pieces are shaded in. What is this fraction? Well, I need to count how many pieces there are total, and that's going to be my denominator. So there's 1, 2, 3, 4, 5, 6, 7, 8 total pieces. I took this one whole rectangle and I split it into 8 pieces. Now, how many are shaded? 1, 2, 3, 4, 5, 6. So 6/8 of this fraction is shaded in green. So 6 out of the 8 pieces are shaded in green, so that gives me 6/8 as my fraction. Whoops, skipped ahead too far. Okay, now let's talk about if fractions are equivalent. That means are fractions the same? Because equivalent sounds like equal, so it means are the fractions the same? So if I look at these two pictures and I see 2/6 and 1/3, what do you think? Are they equivalent or not equivalent? They are equivalent, and the reason why is because the same amount is shaded in both rectangles. I know it says circles, but it's supposed to be rectangles. So both rectangles have the same amount shaded. Are these two fractions equivalent? Well, let's look at my pictures. Are they equivalent? No, because this one has way more shaded than this one does. So no, they are not equivalent because the same amount is not shaded. Okay, so that was a quick review. Now let's talk about improper and mixed fractions. Improper fractions, that means the numerator is larger than the denominator. And mixed fractions, these fractions include a whole number and a fraction. So before we were talking about just parts of a whole. Now we're going to talk about whole numbers and parts of a whole. So if you look here, I have, these are all cut into 4 pieces. All together, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 pieces, but we're just concerned into how many pieces they're split into. Don't get confused and put that the denominator is 12 because each circle is not cut into 12 pieces. Each circle is cut into only 4 pieces. So to write that as an improper fraction, my denominator is going to be 4 because each circle is cut into 4 pieces. Now I want to know how many are shaded in yellow. Well, there's 4 here, 8 here, and these two makes 10. So 10/4 are shaded in. If I write it as an improper, or a mixed fraction, sorry, this is the improper. If I write it as a mixed fraction, I say that 2 whole circles are colored in, and then 2/4 of this circle is shaded in. So that's how you represent a mixed fraction and an improper fraction. You have to understand that these are represented as the whole number 1. So I have 1, 2, whole circle shaded, and then 2/4 of this one shaded. Or If I counted up all the fourths that are shaded, it's 10, but it's still fourths. It's always going to be fourths because it's cut into fourths. Let's look at this one. These are cut into, let's count, 1, 2, 3, 4, 5, 6. So my denominator is always going to be a 6, no matter what, because they are cut into 6 different pieces. Now, let's go and count how many are shaded in this bluish green color. So I know that there's 1, 2, 3, 4, 5, 6 in this one, 7, 8, 9, 10. So 10 sixths are shaded in between these two circles. That's an improper fraction. To write it as a mixed fraction, one whole circle is filled in. And then 1, 2, 3, 4. 4, what's my denominator going to be? Sixths, because it's still cut into 6 pieces. So this is my improper, and this is my mixed fraction. Let's move on to this one. Again, let's count to see how many pieces this circle is split into. 1, 2, 3, 4, 5, 6, 7. So no matter what, my denominator is always going to be 7. Now to write my improper fraction, I need to count how many are shaded orange. So there's 7 here, 8, 9, 10. So there are 10 sevenths for my improper fraction. And for my mixed, 1 whole and 3 sevenths. My denominator is always going to be 7. It's not going to be 13 because that's how many are shaded in. It's not going to be 20 because that's how many are shaded in. It's always going to be how many pieces each circle is split into. If I have 20 circles, they're still going to all be split into sevenths if I'm using this example. So the denominator is always going to be how many circles or how many parts your circle is split into. Okay? Don't get confused and try to write how that there's 14 pieces. Well, yes, there are 14 pieces, but each circle is split into 7 for this example. All right, let's look at this one. How many parts is this rectangle split into? 1, 2, 3, 4, 5. So 5 is going to be my denominator because they are all split into fifths. Now I'm going to count and see how many are shaded in red, and that's going to be my numerator. 5, 10, 15, 16, 17, 18. So 18 fifths is shaded in red. 18 pieces. Okay, if I were sharing this, I would have 18 that would shade it red, but I still cut them into fifths, so that's going to be my denominator. Over here, my denominator is going to be a fifth because I have 1, 2, 3 wholes and 1, 2, 3 fifths. So my mixed fraction is 3 wholes and 3 fifths are shaded in. My improper fraction is 18 fifths are shaded in. Let's look at this one. This is cut into 1, 2, 3, 4, 5. So this is cut into fifths. How many do I have shaded in red? That's going to be my numerator. My denominator is still going to be 5 because each circle is split into 5 pieces. So I have 5, 6, 7, 8, 9, 10, 11. So 11 fifths is shaded in as my improper fraction because it's not very proper because the numerator is larger than the denominator. And then how many holes do I have shaded in? Well, I have to move this whole piece over here. So that would make 1 hole, 2 holes, because I moved 1 piece over here to make it whole. So that's 2 holes and 1 fifth are shaded in as my mixed fraction because I have 2 whole circles and then 1 fifth. Even though this isn't a hole, I can move one over and make it a hole. So don't let that trick you. This one looks really tricky, but we can work through it. 1, 2, 3, 4. So that's going to be my denominator because each one of these is split into fourths. Now let's count. That's 4, 5, 6, 7, 8, 9, 10. So 10 fourths are shaded in. Now how many holes for my mixed fraction are shaded in? Well, I can move this one piece over here. So that makes 2 holes and 2 fourths. So that's how much is shaded in. 2 wholes and 2 fourths. So I hope that this helps you with mixed and improper fractions and just numerators and denominators. Again, watch this video as much as you need to, and if you have any questions, you can ask myself or Mrs. Drake. Even if you're not in our class, sometimes it helps if you ask somebody who's not your teacher. So please watch this video as many times as you need to, complete your homework and turn it in, and please ask any questions if you don't understand. Have a great day.